perfecting standard work protocols on a factory floor solves only half the operational equation. If deviations from that standard remain invisible, the system still fails. This leaves supervisors trapped in a daily cycle of data gathering. They spend the majority of their shift walking the floor, asking for status updates, rather than actively solving production problems. Look at the scale of these operations. In a dense, complex manufacturing environment, major bottlenecks easily hide in plain sight. Down on the line, workers are buried deep in physical tasks. If a part is missing or a tool breaks, they cannot easily signal a delay without abandoning their station. The solution lies in how our brains process information. The human brain interprets visual data 60,000 times faster than text. Relying on verbal updates, spreadsheets, or end-of-day reports introduces massive latency. An issue that takes 30 seconds to parse from a written log can be communicated in a fraction of a second with a simple color code. This principle drives the ultimate benchmark for a lean operation, the 5-second rule. Any manager must be able to step onto the factory floor and determine if the current system status is normal or abnormal within exactly 5 seconds. Visual management functions as a multi-tiered engineering architecture, embedding logic into the physical workspace. A mature visual system shifts the operational burden. It removes the reliance on a manager's memory or data gathering skills and embeds the real-time status directly into the physical environment. Consider a mid-sized machining facility operating 20 CNC machines. To a supervisor walking the floor at midday, the machines are loud and the operators are occupied. The factory appears to be running at full capacity. Yet by 5 o'clock, the daily production report reveals that output has reached only 40% of the target. The deficit stems from microstoppages. Tool breakages and quality control wait times occurred throughout the day, but without a clear way to signal them, they went entirely unnoticed. This specific type of operational blindness is resolved through a 4-tier visual engineering hierarchy, beginning with Level 1, visual indicators. Visual indicators provide passive routing. They establish standardized locations for materials and clear, unambiguous identification for parts and pathways. The immediate return on Level 1 is the elimination of unnecessary motion. Workers no longer waste time wandering the floor searching for tools or directions. The architecture scales up at Level 2, visual signals. This shifts the environment from displaying passive information to broadcasting active alerts. Tools like andon lights demand immediate attention. The exact second an abnormality occurs, they trigger predefined response protocols across the floor. Managers retrofit andon lights onto 20 CNC machines. Machine 5 breaks, flashing red. Machine 12 needs quality control, flashing yellow. Machines now broadcast their own errors. The supervisor moves instantly to the red nodes without investigating the entire floor. By eliminating the time spent discovering and communicating problems, the Siam Precision Parts facility saw its overall equipment effectiveness reach 80% by the end of the first month. By forcing abnormalities to broadcast their presence, the factory provides an accurate view of production capacity and actionable flow. Identifying problems quickly is crucial, but Level 3, visual controls, takes a different approach. It restricts human behavior to prevent problems from occurring in the first place. Visual controls enforce physical and operational limits without requiring a supervisor to monitor the behavior. Consider a shadow board used for tool management. A missing wrench leaves a glaring visual hole in the shape of the tool. Any worker recognizes the discrepancy in a single second, preventing a 10-minute search later on. For inventory management, factories use min-max lines. A bright red maximum line is painted directly onto a storage zone wall. The operational trigger is absolute. The moment boxes cross that red line, the upstream manufacturing process halts. This specific visual control autonomously prevents overproduction, keeping inventory strictly tied to actual demand. The apex of the hierarchy is Level 4, visual guarantees, a concept commonly known as poka-yoke. Poka-yoke provides physical error proofing. It is designed to make executing a task incorrectly physically impossible. At this level, the physical geometry of the workspace is altered to prevent errors. An asymmetrical jig, for example, will physically reject a part if the operator attempts to insert it backward. The objective here is achieving zero defects by designing human error entirely out of the system. As an organization moves up these 4 tiers, its operational strategy evolves. It shifts from merely observing its processes to actively constraining them toward perfection. All 4 of these visual tiers feed into a central management hub, functioning as the central nervous system of the shop floor. The primary physical tool for this integration is the manual Gemba board. These boards track 5 core indices: safety, quality, cost, delivery, and people. Lean practitioners insist this data be updated manually with a marker. Automated digital screens often become passive background noise that workers eventually ignore, whereas physical writing forces active engagement with the numbers. This chart shows the danger of daily averages. An acceptable end-of-day total line on the left can mask severe volatility. Hour-by-hour tracking on the right reveals a massive drop in production at exactly 11 a.m. Daily aggregates hide failures. Tracking output hourly forces the team to identify root causes and resolve them before the shift ends. But there is a reason these highly engineered visual systems frequently degrade into ignored monuments on the factory floor. If a manager uses a red missed target indicator as a reason to reprimand a worker, the entire visual system dies that day. To protect themselves from punitive management, operators will immediately begin inputting fake data, painting the board green to hide actual defects. Psychological safety is a strict mechanical requirement in Lean. A red indicator must trigger an immediate coaching response, never a punitive one. When a supervisor sees a red number on the board, their required response is to ask, "What obstacle can I clear for you?" Visual management strips away the noise and the guesswork. It establishes a single source of truth that forces leaders to face reality, while empowering their teams to execute rapid, high-level problem-solving.